In the last lecture, we talked about how Earth's climate moved from the last glacial cycle 20,000 years ago to the present climate, and during that process we saw there were some abrupt changes. We saw the Heinrich event when the Arctic region cooled, then we had Polaroid warming which followed that, then we had Younger Dryas cold event. So all these abrupt changes, we were able to understand what caused these changes and how they were connected to the Atlantic meridional ocean circulation. Today we will talk about ice ages. Okay? And before I go that far, I want you to understand the whole range of time scales that we are dealing with when we talk about climate. If you are worried about weather, you will only worried about what will happen tomorrow. That is weather. Okay? Somebody may be interested in what will happen a month from now, okay, or 10 days from now, that is intra-seasonal. Somebody else may be concerned about how will be the climate next year, the annual cycle, winter to summer. And in India, the concern is always about how will the monsoon behave next year, that is the interannual variation. Okay? And then we worry about longer term decadal variations which do occur in the case of the monsoon. But when you talk about climate change, we are talking about scales of the order of hundreds of years. Okay? And the present concern is about how will our climate change in the next 100 years on account of the increase in carbon dioxide. Okay? But now we are going to talk about much larger time scales, 1000 years, so-called millennial variability. Okay? For example, the last 1000 years before 1850 was fairly stable climate. Then there is interest in scale from 10,000 to 100,000. Okay? That is related to the changes in Earth orbit around the Sun. Okay? And ice ages come in this time scale. And if you go to even longer time scale, million years longer, then you have to worry about how the continents moved and how it altered climate. We will briefly mention it when we talk about snowball Earth. So I want you to remember that there are so many time scales. In each time scale, certain phenomena are important. As you go to longer time scale, things change. When you talk about ice ages, you are worried about how the radiation coming on Earth in the polar region changes because of the changing orbit of the Earth around the Sun. Okay? That is what our focus is. Now you might ask, why should we know all about this? Because if I am worried about the Earth's climate in the next 10 or 100 years, why should I worry about what is happening in a millennia time scale? Now this interest is there only because we have built climate models in the last 50-60 years which are becoming more and more realistic. They are not perfect, but they are still realistic. And once having built this model, we would like to test it under all conditions. Okay? Some of the models are tested for weather forecasting regularly. Every day forecast is made, you can check what is going wrong and improve it. Then there are seasonal forecasting now available. So every season people make forecasts of the monsoon, and at the end of the season we find out whether it came out right or wrong, and if it came out wrong, one tries to find reasons, try to improve the model. In the same spirit, we would like to know whether our climate models can simulate the ice ages. Okay? Now we saw in the last lecture that the climate models were able to simulate the abrupt changes in climate that occurred when we moved from the last glacial age 20,000 years ago to the present interglacial age. There were abrupt changes. warming, cooling, and we are able to monitor that through proxy records as well as simulated using climate models, and the two combination enabled us to explain why those changes occurred. Now we go to a more challenging problem. We know from the ice core data that there were many ice ages in the past million years. Okay? So we would like to look what they are and see whether climate models can explain the occurrence of ice ages periodically. Okay? Now, how do you know ice ages occurred in the past? And that's always proxy evidence. The earliest hint that ice had occurred on land which do not have ice today is the presence of rocks, okay, in places where they should not be. If you look at a rock in a given place and it does not look like the rocks in the surrounding area, you have to conclude that this rock does not belong locally. It migrated from somewhere. Okay. Now the question is, rock is not a human being, cannot move. So if the rock is appearing in this place where it should not, then something should have moved it. Okay. And that movement is caused by glaciers. So this was inferred more than 150 years ago, that the rocks that were not looking like the local rocks must have come from some distance away, and the only way large rocks can be moved is by either flood or ice. Flood can move the rock a short distance, but not very long, maybe a kilometer. But ice can carry rocks for long distances. Okay? So the appearance of these rocks known as glacial erratics, because they are erratic, they are not normal. Okay? And this is from Yellowstone National Park, which had very large glaciers 20,000 years ago, and when the glaciers retreated, these rocks were left behind. Okay? So by looking at these erratics, the climatologists were able to say that there was glacier in this place 20,000 years ago. Okay? And with further analysis, they can also identify places where how the ice retreated and how far it went. Okay? So most of the inference about ice ages is through these geological evidence. Now there are a lot of terms used when you are talking about ice age and the transition from ice age to the interglacial, and some of the words have been used already. So I want to make sure that all of you are clear about these terms. When there is a short cold period, it is not called glacial, it's called stadial. Stadial means a cold period which is less than 1,000 years. Okay? This happened during the Heinrich event, which we discussed in the last class. For 1,000 years a certain region was cold and then it became warm. Interstadial is a warm period, but it is smaller than 10,000 years. Okay? Now your warm period is very long, like the present warm period we are living, which is more than 10,000 years long, then it is called an interglacial. So we moved from the last glacial 20,000 years ago to the present interglacial around 12,000 years ago, and we continue to be in interglacial for some time. Now glacial periods are much longer period, typically have a period of 100,000 years, which is what we are going to discuss. The ice age periodicity is typically 100,000 years. Now how are we discovering what happened during that period? We discussed this briefly earlier. We talked about Lake Vostok, which are the deepest ice sheet in the world. So this ice sheet, people went all the way there and then drilled all the way almost to the bottom where there is a lake. Okay. You may wonder why is there a lake here? Remember, the huge pressure of ice is acting on this, and hence due to high pressure here the ice melted to become water. Okay. So, this long ice core provides us with the longest record of how the Earth's climate changed during the last 420,000 years ago. Okay. And in this ice sheet, the snow falling on the surface gets compacted until it reaches about a depth of 50 meters, where the ice is completely compacted, but there are a few bubbles of air, and we saw that this air, composition of this air tells you what was the amount of carbon dioxide and methane in the atmosphere 400,000 years ago. This is a remarkable feat achieved by human intellect, and I would say a great adventure of people who went all the way to Antarctica and got this ice core. Okay. Now, there are many ice cores. We discussed it, and I will talk about more in this lecture. Now, this ice core, based on the drilling at Vostok, showed clearly this is the local temperature, and showed that the local temperature was as low as minus 10 degrees centigrade annual mean 4 times in the last 400,000 years. That means there were very large ice sheets about 4 times in the last 400,000 years. If you look at this maxima as the peak of the ice age, you can say ice age repeated itself approximately every 100,000 years. Okay. So, this is a major discovery that in the last 400,000 years there were 4 major ice ages. In between there were 4 major interglacials, warm periods, including the one today. We had one interglacial today, and another one I mentioned 125,000 years ago, and the other one was 340 and then 415. Okay. So, the question is, these changes in Earth's climate which cause ice ages occurred well before human beings began to dominate the planet. Okay. So, the reason why the ice ages repeated every 100,000 years is because of natural causes. Okay. So, a lot of people wondered what were these natural causes, what caused the ice ages to come every 400,000 years. And there were many speculations, and the one which was most believable was that the Earth orbit around the Sun is not a circle, it is an ellipse. Okay. And secondly, Earth's axis of rotation is inclined to the plane in which Sun and Earth are moving. Okay. And that has not remained constant. And lastly, where the Earth rotation axis is pointing, is now pointing towards pole star, that has changed. That is called precession. So, 3 different factors kept changing on account of the influence of all the other planets on the rotation of the Earth around the Sun. Okay. Gravitational effect. Okay. Now, although this was proposed by an astronomer named Milankovitch from Serbia, he made this proposal 100 years ago, when this data was not there, this data was not available. So, his speculation was not taken seriously, and only after the ice cores were drilled and this unusual data came that his work done almost 100 years earlier was taken seriously. Now, we talked only about the last 4,000 years. If you go and drill into the bottom of the ocean, in the ocean sediments, you can go to a much longer period. So, here is a data from ocean core, which shows a period of 5.5 million years. Okay, 5.5 million years, and based on calcium carbonate present at the bottom of the ocean, based on that you can derive temperature of that ocean at that time, and then you see that the Earth's temperature equivalent to what we observed in Vostok fluctuated quite a lot in these 5 million years. But the main thing you have to notice here is that the fluctuations were more frequent 4 million years ago than in the last million years. In the last million years, we can say based on Vostok that ice ages occurred every 100,000 years, but 4 million years ago it occurred every 41,000 years. So, the periodic occurrence of ice ages has changed its character. It occurred every 100,000 years in the last million years. Before that, it occurred every 40,000 years ago, 40,000 year period. So, this is one of the biggest puzzle in the study of Earth's climate. Why did the occurrence of ice ages, which was every 100,000 years in the last million years, there were 10 ice ages in the last million years, but if you go back in time, the proxy data shows that they occurred more frequently every 40,000 years, 41,000 years. So, this is what we are going to discuss in today's lecture, why and what could be the reason. Now, let us now focus on the last million years, and you see around 10 times when the temperature was very low, global mean temperature here, and you see only 2 warm periods and rest of the time the Earth is cold. Okay. So, our focus is on what caused the 100,000 year cycle of ice ages. Now, this figure you already seen earlier from the Greenland ice core, which showed how we came out of the last ice age. There was a sudden warming event called the Berling aneroid, which caused a temporary warm period interstadial, but then again it plunged into the next cold event stadial, okay, for some time, about 2000 years. Then finally it came out and became quite warm and remained warm for the next 12,000 years. Okay. This you already seen. Okay. This is just for your reference. But you are going to talk about much longer time scale. Now, this shown again that the last interglacial was 125,000 years ago, and we are in the present interglacial here, and people expect us to go to the next glacial, but that is not going to happen for another 25,000 years. Sorry. Yeah. Now, before I go on to some details about ice ages, I want to refresh about the simple model for the global mean temperature, which I derived very early in the course based on radiation budget, and we saw that the temperature of the Earth depends on the incoming radiation, the amount of ray reflected, the albedo, amount of solar radiation absorbed A, and the infrared emissivity or absorptivity, which tells you how much of the earth radiation is absorbed by the atmosphere. Okay. And we saw that this model, given the present observations of albedo of 0.3, solar absorptivity of 0.2 and emissivity of 0.95, gave us the temperature of 288 degrees Kelvin, that is 15 degrees centigrade, which is close to the present observed temperature, global mean temperature of the earth. Okay. Now, if you slightly modify these numbers, especially the albedo, because there are lots of ice sheets during the last glacial, so increase it by only 0.02, that is a small increase, keep the absorptivity same and assume emissivity was reduced by to 0.9 because there was less carbon dioxide and less methane, you will get a value of 282 Kelvin. This is a 6 degree drop, and this is very close to the global mean temperature during the last ice age. Okay. So, that is very nice that a very simple model involving only the incoming radiation, albedo, emissivity and absorptivity can explain why the last ice age was 6 degree colder than today. Okay. But also remember that this shows clearly a very small change in emissivity of less than 2%, around I would say less than 10%, and a change of emissivity which is around 5% was able to change the global mean temperature by 6 degrees Kelvin. So, this shows that Earth's climate is very sensitive to small changes in the ice sheets and small changes in the amount of gases in the atmosphere which cause the greenhouse effect. So, that is a reminder to you that Earth's climate is sensitive to small changes. An ice age can come if the albedo goes up by around 10% and the emissivity decreases by around 5%. Now, let us come to the question about what caused the ice ages. Within the earth, there are a number of factors which cause the amount of CO2 in the atmosphere to change. This is known as the carbonate silicate cycle. I mentioned it briefly in my early lectures, how carbon dioxide is able to react with the rocks and form calcium carbonate, okay, which is ultimately stored in the deep ocean, and thereby carbon dioxide is removed from the atmosphere, and that can cause the atmosphere, the earth to become colder. Okay. The other important natural factor is volcanic eruption. When there is a huge eruption which covers the entire earth with ash and dust, which goes up to around 20-30 kilometers, then it can cool the earth temporarily by reflecting the solar radiation, and if this eruption is large enough, then that cooling can go on for a long period. Okay. The other thing which can change the temperature of the earth is mountain building. So, as the Indian plate collided with the Asian plate to form the Himalayas and Tibet rose, it exposed more of the rock for weathering, and it is believed that this was one of the causes for cooling of the earth from the time it was very warm 50 million years ago to today. The carbon dioxide kept declining because of weathering. That is one postulate. Okay. And of course, the relative location of land and ocean is very critical to Earth's climate. We will discuss that when we talk about the snowball earth. Okay. These are internal to the earth. Now, we come to external factors. The external factors are changes in incoming radiation of the sun. Okay. I pointed out earlier that when the sun formed about 5 billion years ago, its radiation output was less than today, okay. And as the sun's nuclear reaction reached steady state, its radiation went on increasing. So, what we have today is much larger than what it was when the earth was formed. So, at that time the incoming radiation was smaller, so one could have expected an ice age at that time. Okay. But we will not talk about that, that is very far away. We will talk about what happens to the earth orbit around the sun, which changes because of the eccentricity of the earth's orbit around the sun, change in the tilt, so called obliquity, and the change in position where the earth is pointing. Okay. Now, this has been tabulated by astronomers for a long time, and we have a fairly accurate idea of how Earth's orbit around the sun varies over the last million years. Okay. We have good data. Now, here is a picture of how the earth moves around the sun in an eccentric orbit with the present inclination of 23.5. At present, the earth is closer to the sun in winter, 4th January, okay, or 3rd January here. But this was not so 10,000 years ago. Right now, the summer, the earth is far away from the sun, in winter is nearby, and this was one of the reasons why the last glacial ended. The last glacial ended because the earth orbit around the sun was such that the polar regions received lot more radiation, which caused the melting of ice sheets. So, that was one of the hypotheses proposed by Milankovitch. But the interesting point is that if you calculate the total amount of radiation falling on the entire earth, okay, not polar region, entire earth, then one can show that radiation varies as 1 by 1 minus epsilon square. Epsilon here is eccentricity, not emissivity, eccentricity, and square root. Okay. Now, eccentricity of the earth is not very large, 0.04 at the most, okay, the highest value, and right now we are close to 0 eccentricity. So, this cannot cause much change in earth's radiation. So, role of eccentricity cannot be very large because its contribution to the change in total radiation arriving on the entire earth is not very large. Okay. So, something else must be causing it. Now, Milankovitch argued that minor irregularities in Earth's rotation and orbit are sufficient to alter the amount of radiation that Earth receives any latitude and hence can change climate. In 1941, he proposed that if there is less radiation falling in the North Pole region in summer, then the ice will start building up more and more, because less radiation, less ice is melting. Okay. So, he argued that if there is less radiation falling in the North Pole region, then the snow will survive into the next year because it is not melted, and he argued that this will be caused by variations in the Earth-Sun geometry, but he was not believed. Okay. He did detailed calculation about how much radiation is falling in the polar regions, very accurate calculation done by hand. Remember that all this work was done 100 years ago without calculators, without computers, all done by hand. These are amazing people who did very accurate calculation without access to a calculator or a computer. So, think of their tenacity. Now, what are the things he looked at? He looked at the changes in the eccentricity of the earth orbit around the sun that has a periodicity of 100,000 years. Okay. Now, remember in the last million years, ice ages occurred every 100,000 years. So we may conclude that somehow changes in eccentricity played a role. Okay? But as you saw, eccentricity does not alter the amount of radiation falling on the Earth. Annual mean, global mean doesn't change much. Next we have the tilt of the Earth's axis, and so this is right now 23.5 degrees, and it has been changing from 21.5 to 24.5. Okay? And other one is of course where the Earth is pointing, and the tilt changes with a cycle of 41,000 years, while the precession where it is pointing changes with a cycle of 23,000 years. Okay? So these are the three things which contribute to the ice ages, and we will now look in the next lecture for how these three things can alter the climate of the Earth. Thank you.